Just wait a little bit. We will have. So before I start, I want to do a poll because of the someone sent me an email about next Thursday. So let me launch the poll first. So the question I'm asking is because of next Thursday, 8:30 is you have a course choosing that started oh no, 8 a.m. sorry, it's 8 p.m. sorry, it's not 8 it's 8 p.m. sorry, not 8 a.m. Oh, sorry, I do it wrong one, sorry. Sorry, let me edit it. Sorry for the wrong question. PM, so I just change it. Let me do the other one, sorry. I feel I do it wrong. So yeah, sorry. I'm asking you to see, I need to change it to 1 hour to facilitate the exam, of course. 1 hour will be shorter than 2 hour one. Okay, I guess most of you have voted. Let me, I see. Okay. So, given the poll, let me show, maybe I end the poll. Just 2 more people to vote. If no, I guess I should show the result. So this is the result. So as I repeat, because I received multiple emails from this section, other section, saying that worry about the cost registration. So I'm thinking, because if I do a make up, then you will be in a large scale, then would be not really a good idea, right? Because makeup is supposed to be a small scale. So I'm thinking to make the exam shorter. Of course, I'll cut the question also in that case. Seems to be most of you prefer, at least more than half prefer 1 hour. So I check with other section and announce it to see what can be done. Just because they just let me know at last minute, so I don't have any plan at the moment. But before we start, do you have any question? Because today we'll finish all the material, and then next week we will have a quiz and also review, and then Thursday then we'll have a test at night. Any question? Okay, I'll let you know. I'll put the announcement on the Blackboard after I talk to the other group and see what can be done, because I want to make sure that the exam is fair and also uniform as much as possible, because we want to reduce the makeup as much as possible to make it the smaller scale. But anyway, any question before we start? Oh, I forgot to share the result. Okay, so this is the result. So that would be something like this. So most of you are not year 1 student, but people worry about the registration. So it's kind of, many of you are very altruistic, okay, which is good. So more or less people are, it's okay to be 1 hour, and so let's see if the other group also is similar. If that's the case, I will make it 1 hour. Of course, I'll cut the question, so don't worry, it's not going to be the same exam. You'll be reduce the number. I'll cut the number of questions down. But anyway, let me start. If you don't have any further question, let me get started. Okay, so because I'm sorry I'm start late because of the traffic and also the administrative thing. So we will cut the break short to 5 minutes. But don't worry, we'll finish everything, because this last class we were supposed to finish the regression and also the Excel. So just to, any question before we start? Any question? If no, then let's get started. You will be much. So, oh, there's a question. I can't see the question. Why it's not coming out? Should I stop the share? Oh, do we have quiz today? Next Tuesday, because Thursday we don't have class because of the graduation day. The second question, will the exam ask about proof? No, you not ask about proof. So everything in the grade is not intended to be test. So it's the application So it's driven by applying it, not proving it. Grading method. I guess this course, I guess, is similar to other classes. It's like we are no longer grading on the curve. I guess you take the policy, if I understand correctly, is based on your absolute merit. Of course, it will also somewhat, relative will make some sense, but it will not be, say, fixed percentage people get A. So I guess more or less my feeling is like grading on the curve with the lower bound, right? Then you will, if you do better, you'll be doing better, right? Somewhat like that. But the grading will be following the syllabus. What we said is how the graphs of it. There's no absolute point to map. There's no absolute point mapping. Pass or fail. I guess I don't know who get pass or fail when we grade. So we just grade everyone, and then we'll tell the grade, and then it will be converted to pass and fail, not by me, but by the school. So I just give the grade. But there's no fixed number of A that would be same. So if you deserve an A, you deserve an A. So don't worry, just work hard and then you get rewarded accordingly. So there's no worry about that too many smart people, then you can't get an A. So if enough people get A, then I will fight for you. But at the end of the day, it's just like I recommend grade, and what is ultimately will be determined by the school. So I don't have. I guess so. If the system, I think it's uniform. It's like I think in my days when I in switch case, everything is grading on the curve, but now I think it's not an absolute policy for that. If I understand correctly. I cannot say whole series case because I don't really know enough about everyone, but as I understand, it's not absolute grading, is not an absolute policy for everything. Can you use Excel? Yeah, you can use Excel. Okay, you can use Excel. That is the reason why it's not an exam, it's a text, because exam we don't allow to use outside help. That's why we are arranging a decentralized exam. That's because of when the final test will be next Thursday at 7:30 p.m. and then we'll decide 1 hour or 2 hours depending on the cases, because as people have suggested, year one student, they have to choose the course at 8:30. So I'm thinking cut it short from 2 hours to 1 hour. Of course, I'll cut the question as well. So that's why I'm asking at the beginning of the class. Is that clear what we're doing? Is that okay? Any further question will be next Thursday. No, the weighting of the test is not changing. I just cut the question. No. It's okay to miss one quiz because I would just I just take the best out of it. Yeah. Any further question? I haven't decided yet. Is it 1 hour or 2 hours? But if 1 hour, which is likely, then it will be yes. Because to make sure that you don't miss the registration deadline. So I think the difficulty is similar because I cut the question. So you should not be an issue of the difficulty, but rather I just cut the question down. Yeah, I mean the quiz is just attendance. Yeah, the pattern. I think I said the Blackboard. The pattern means you mean the exam format will be similar to what I uploaded in the past paper. Yeah, somewhat only the long question. Yeah, long questions. You can check the past paper up in the Blackboard, which download from library. Then you can take a look, and then you will have some idea what is the. Well, you're not putting the Excel, so the test format you will be doing is you will be writing your steps on your paper, and you take a picture, and then you will also input the very short answer on the blackboard. So as a double check to make sure it's a double checking procedure. Well, you're not copying your Excel answer there. Use Excel just to help you say, you just write down the step. Okay, here I use this function to arrive this answer. No, I don't care about Excel file. There's two things they submit. You submit your process, use your pencil and paper. In case in the step you use Excel, you just write down the function you use, and then, yeah. So suppose you use this, and then, yeah. Okay, any further question? If no, then I mean, I'll put more clear instruction on the blackboard again, and then probably I'll put the first page. Homework 1 is graded. I think it's graded. But I think the TA is putting up. If I use Excel writing and over I don't know, I'm not sure what you're asking. But just make sure that people understand how you arrive your answer. Okay, that is the only thing I'm asking. If it's clear to the standard, right? Then it's clear. Just use common sense. It's not. I'm asking a lot. Just like in case someone, your classmate, read your work, would they be able to follow, right? If it is clear, then it's clear. If not clear, then it's not clear. That I think it's not excessively asking. But because the reason I'm asking is because of the online exam style. Otherwise, if it is on-site, then I don't need to worry. Previous homework? I think the TA said, I asked TA several days ago, I think they said he's going to release soon. As again, do we need to write function? Oh, I think that's a very clear idea of, right? Just like if you write this, right? Then you may just like by norm as this 3 maybe equal to what, then you just give a reason why this is true. Something like that. Something to give some reason why, how you arrive this answer, right? If this is the case, you just tell, oh, this is the result. Okay. Yeah, somewhat like that. I mean, just for illustration. Not saying that this is, but just the idea, just make sure that if you use Excel in your calculation, just showing what kind of step. Okay. So I asked the TA to put homework 2 first. I think homework 1 will also be ready. I think he has graded it, put it together. And then homework 3, I think I cannot. We just deadline, so I don't think we can release it. Okay. Just home. So as I said, the difficulty will be similar to other exams that you'll see in the blackboard. Okay, so it will be similar level. my class will not be more difficult than other class that you might have took or you are taking in the other one. Okay, is that clear? It's not particularly difficult, it's not particularly easy. They were similar level. But I mean, introductory statistics, so that the difficulty is more or less fixed. Okay. Any more questions? I'm not sure your question. No, the class will be same level as other class that you took for statistics. I cannot tell you whether you should take pass fail or not. But what I said is the difficulty will be similar to what have been used in the past papers uploaded in the Blackboard. If you feel comfortable answering those, then you should be okay. If you think you cannot, then maybe pass fail is safe choice. But it's all up to you. I cannot recommend what should be. But that is, you take a look and see if you feel it's very difficult, then you should you might want to, for safety reason, you may want to take a pass fail. Otherwise, yeah, because exam is like half, right? So if you shouldn't be too difficult. Any more questions? No, then let's get started. So yeah, if you would say you will be, someone also asked whether similar to quiz. I guess quiz will be, yeah, will somewhat similar to quiz, and also the past homework also similar. I think homework is slightly more difficult, but I think more or less the same. So if you're able to handle the quiz or homework, then shouldn't be an issue. Whether you get an A is I cannot sure, but it shouldn't be a big issue. I mean, it shouldn't be a big issue to get B plus or above, but otherwise, if you unable to answer those, then maybe you worry you don't want to get a B or B minus, then you probably need to get a pass or fail. But it's anyway. So let's get started. So linear regression. So we study relationship between two variables, right? Education and income, advertising and sales, structures, and recovery time. So the data we have is a pair data, right? X1 and Y1, X and YN. You try to best fit all the point. So basically, you draw a line for the dots. Okay. So the least square method is trying to have a line which is by giving us alpha and beta, which is a line, the intercept and slope, and you have the model join this line, and you find the vertical distance. You want to minimize the vertical distance by finding alpha and beta. I hope that's clear. You just try to find different line that try to, by changing alpha and beta, to make sure that the vertical distance is minimized. Okay, so that is the idea. And the just hopefully you will remember, if you try to remember one of the equations from this class, of course not for exam, but hopefully still remember, is the slope will be given by covariance xy over variance x. It's basically some kind of rescaled covariance for the slope. Right? If you also divide it by variance of y and take a square root, actually this is a correlation coefficient, right? So it's related in this sense, and later you will see they are somewhat related somehow. But anyway, we'll be focused, we'll talk about this class. And the slope, sorry, the intercept is given by the fact that the line passing through the center. So that's why that would be the case. So a simple linear regression is trying to minimize the difference, okay? And last class, we talk about how to derive the equation, and we make some assumption on the data generating process. The y come from the x according to some fixed parameter. So alpha and beta plus some random term, okay? X is non-random, okay? X is given. There's no variation on this, but there's a variation on epsilon, okay? And the error are 0 and fixed variance not correlated, okay? And the Gauss-Markov Theorem, which we don't prove, you just need to know, which said the least square estimator, what we have is just unbiased and very efficient, okay? And the interpretation, okay, we call X the independent variable, right? Just to just independent variable, okay? And this is we call the Y is called dependent variable, okay? So the interpretation is also usually is like when X is 0, what is on average Y value is. This is when X goes up by 1, on average how much Y goes up by 1, okay? Just remember it's on average. And alpha would make sense if X is around 0. If X has nothing around 0, that's mostly garbage, okay? And beta, why we have the beta showing positive or negative or 0. And the significance of this is important. You need to do hypothesis testing on this, okay? That is what we talked about last class, which essentially said the importance of this, okay? And the next thing is estimating residual, estimating sigma square is by S. We are not proving why this is a good estimator, but this is a good one according to some criteria. And this estimating the sigma will be useful for hypothesis testing. Otherwise, we don't care, right? We care because we want to check the how alpha and beta are different from 0, right? Or different from certain number. And we have proof if the error is normal and this alpha hat according to this normal distribution, and then this gives us, this will give you T distribution, okay? And do remind you that how you do it in Excel, okay? And interval estimate, also the same idea, okay? So same for the beta, okay? Is a Gauss-Markov Theorem that would be beta had equal to beta. And similarly, you have the t-test, okay? And remember the Excel, when they ask, this is 0, okay? The Excel will give you 0. Okay. And this is a common level, the same. So we just cover up to here last class. So any question about the material? Okay. If no question, then I guess we start or no for any question. Oh, as I said, we don't explain why this n-2 because this is to explain, okay, relatively, the idea was the following. To explain will be much more elaborate, but the idea is like this. When we have S square for one variable. Or maybe I just use, I go to the, use the black whiteboard. So if you remember, when you have one variable, okay, we usually estimate by this because this is unbiased estimator, right? Okay, turn out to be, if you, in our model, we have x and y. That is, you have y I minus this guy, okay, and y over 2, okay. The one reason is, you can imagine, coming from the fact that you have alpha hat, beta hat, xi, and how do you calculate this? Oh, sorry, how do you calculate this guy, right? Is coming from the fact that this minus this guy, right? So in that case, intuitively, you have estimate to mean, okay? So you lose 2 degrees of freedom. So that's why minus 2. Same as here, you have fixed this one. So we have 1 less degree of freedom. So that is what usually textbook, if you read other textbook, they will explain in this way, okay? But of course, the best answer is this one. So if you use n minus 2, then it will be the unbiased estimator. So that would be the idea, but we don't prove it here because of the time constraint. And then also, if you want to learn more, then you'll be a lot of textbook there, but that would be the idea. But anyway, that would be the, that's why there would be a chi, more or less like the chi-square distribution, and then they will get t degree freedom is n minus 2 here. So that is the reason, but I cannot give further because of the time constraint. But you can say this is the way that why this was n minus 2. Okay, same for this n minus 2. The other reason you can imagine y minus 2 because you have a point, 2 point, and once you draw a line, then basically you lose 2 degree freedom, right? Because if you're 2 point, then that's actually is a line already. If they only have 2 points, then you do not want regression, right? You start from the third point of fourth point, fifth point onward. So that's why you don't have any thing beyond. Only if you have 3 more points, then you can have some variance. Okay, same as you estimate the idea we said here, right? You estimate the sigma square, right? You only have one dimension data to x, right? If you have one number, then there's no variance to estimate. So you need to have 2. So the first one is more or less you cannot estimate. So that's why n minus 1 in that sense. I hope that can give you some idea. Of course, it's not the real answer, but I think it's a good answer that keep in your mind. And for those who were interested in the math, that will be puzzle you for a long time. It puzzled me for quite a while, but if you really want to know, then you can just take it. But somehow it's sometimes you have to live with the question. It's not. It doesn't like your high school. You can know every single thing. There will be something that it doesn't explain, but we use it. And especially if you're B school student, you will notice a lot of things you cannot explain because of the time constraint. So it will be, we have some tools, we just left in the dark, and that's it. Just like we have a computer, we have an iPhone, we have a smartphone, we don't know everything inner working of the phone, but we know press this button, it will work. But if you want to know, you will be going further. So sorry, cannot go into further more, but okay, any further question? So I guess we should continue because of the time constraint. So maybe we just skip the break. I hope that's okay. So sum of square total, I guess there will be one-way ANOVA here. So it's just yi minus y bar. So I guess this is not something terribly difficult. Okay. So here we have an called sum of square regression is this. Okay, it just the idea behind this is the following. So consider x, this is y, and this is all data point here. Okay, and to estimate y, the easiest you think in your mind is y bar, right? Because to predict y, the easiest thing is to look at the y bar, right? Even without x, right? So that would be the minimum thing we want to do is to explain the difference between y and y bar. Okay, this is something we want to explain, right? Because when I explain the variation from mean, right? Because the prediction for each observation, then the baseline is the mean, right? So we're going to explain this. So that's why sum of square total. And if we have a line, it's yi hat, right? So if you, what you actually explained it, right, is the, what you actually explain is this guy, right? It's an SSR, okay? And suppose one data point, okay? And this is SST, okay? And you notice this is SSE, okay? Of course, the sum of them, square sum of them, okay? You take a square, then you will be sum of the square, okay? Then we will give you SSE, okay? So this is the decomposition. So you would be, what you try to explain, the total can be divided in two parts. One is the SSR, we call it explain the part, okay? SSE is unexplained part, okay? And it's total, okay? Total variation or total to be explained, okay? So you want this is equal. Actually, turn out that this is the sum. We prove it, but that would be the goal. Okay. So if no question, so basically just divide it. What you want to explain in two parts. Okay. One is explained by the model. One isn't. Okay. So that would be the. Any question about this? Okay, we'll try to give you a quick proof of why they're the same. So we'll be quick, so don't worry. To remind you that the proof is not included in the exam, at the text, but just we'll quickly go over why this is true. So I guess most of you are not interested in the proof, but at the least we know in idea how it works, right? In principle. So SST, okay, will be yi minus y bar. So we use the trick that we add and subtract, okay, add and subtract. So they cancel out, right? This is 0, but we just add and 0 there. And we will, what we'll use is a plus b squared equal to a squared b squared plus 2ab, okay? So here is, look at this. This is a, and this is b, okay? And this is b squared, okay? This is a squared. This is 2ab, okay? A plus b squared, a squared, b squared, 2ab, okay? And a squared is SSR, b squared is SSE, okay? So what is left is to prove this guy is correct. Okay. So what here we have is to, what here is to show this guy is 0. Okay. How to show this guy is 0? Actually, you might have expected the y hat I, the average of y hat I should be y bar. So this is come to this, no surprise, this should be 0. But we just need some step to show it's 0. Okay. How to show it is coming from when we derive the alpha hat, beta hat. This is something that FOC, right? First order condition for the or the first derivative, okay, partial derivative over alpha and beta, okay, and that tell us explain the second one. This tells us you put alpha and beta. This is actually yi hat times x will be 0. Okay, so that will be a key we are using. So we are decompose it to this to yi hat. Okay, coming from here. And what we are doing here is to separate two parts. This alpha hat and y bar are independent of I, right? Because this coming from what? This is y bar minus this, and this guy is independent of I. Okay, so it is all independent, so you can take it out. Okay, and what left is here, right? Just time this you give here, and this time that you give into here. Yes. I should have beta. It's a missing beta hat. Sorry, beta hat here. Okay, and from here, from the above, use this one. From the above, this is 0. So this guy is 0. Okay, and the below, this is 0. So this is also 0. So 0 minus 0, that's 0. Okay, but anyway, so this is proving that SST is SSR plus SSE. Okay, and so why we want to prove this particular part? Because this is something very important. Just pay attention now if you are falling asleep. So this is the important thing, R square. Okay, R square is the proportion of y explained by x. Okay, so just recall the graph we have. Let me draw it here to make you more concentrated. Okay, so this is data. Okay, and we have x and y, and suppose we have a bunch of data points. Okay, and what would be the best estimate, right? Would be the y bar, right? This will be the best estimate, right? And if we run the regression, this may be the regression line. Okay, this may be the regression line. Okay, and what you are trying to explain is SST. Okay, what the data has explained it is SSR, and what the data haven't explained is SSE. Okay, here we define the following: R square will be SSR over SST. Okay, or because they sum together, right? So you can write 1 minus SSE over SST. Okay, so that would be the goal that what we're doing. Okay, so that is the case. Okay. Someone may have asked how we get from here to here is because SSR is SST minus SSE over SST, so they cancel out 1, so that's why we have this. Okay, and because it's a fraction, so that means R square must be between 0 and 1. Okay, and turn out to be, okay, maybe surprising to you that turn out that we don't prove this result, but you pick R square, okay? It may not be surprising that this is actually the correlation coefficient R square. So the big R square is actually the covariance xy over variance x, variance y, take a square root, and then square. Okay, so this is something very interesting. Okay, correlation coefficient. Right, maybe I just write it better. I think the not very clear enough. Maybe I should be using better handwriting. Covariance xy, right, would be the variance x, right, variance y. Is that okay? So R square, if you have one variable, the bigger the R square, the better, because your model can explain more. Okay, and that's why here also explain R square is related to correlation coefficient. So that's why when you run simple linear regression, you want to really look at the scatter plot first, right? The scatter plot means if scatter plot is a good one, this looks like line, then it's a good fit, right? Because already the R square actually is the explain how much can be explained by model. Actually, it is the coincide with how fit the data is. Okay. Any further question? Any question? Because other than that, there will be somewhat mechanical showing you all the proof, and that's it. I'm checking with the F test. Oh, they're teaching that as well. Okay, so large R means the definition is here. Is how much the data fit, right? The better the fit, the bigger the R square. So just to show here, R square, right, is the percentage of variation of y explained by x, or explained by variation of x, but just you know what I'm saying. R, the better than the fitter, right? And in fact, remember R square is the correlation. R square is actually the small r square, right? So basically just they more fall into the line. They're close to the line. Did I make myself clear? Okay. So here turn out to be, you can same as ANOVA, okay? You can do ANOVA to test beta is equal to 0 or not, okay? By checking this out, okay? This MSR over MSE, okay? And later you will see Excel. That's how you reject. And here is they use one tail test. In the sense you only reject on the right. So, okay, this is the rejection region. So same as when you do the F test, you always one tail. It's a one tail test, which we don't prove, but it will be the case you want to only reject on the right hand side. Okay, the critical value is on the right hand side. Is that okay? So different from, the question is smaller than R, no, it's reverse. R square is the correlation coefficient. The bigger the R, the bigger the correlation. I'll just show you the graph again. R square is exactly equal to R square when you have simple linear regression. So R2, yes. If it's R square is 1, then it's a perfect line. So R square must be between 0 and 1. This is what we call perfect fit. This is nonsense. Okay. So this is the proof. Actually turn out T and the F are related. Okay, just quickly, I'm not going to detail here, but it's only technical interesting. It's turned out to be the T statistic. Okay, the T square is actually the F statistics. Okay, the proof is very brief. So I quickly go over it. SXY is this, SXY is that. If you write this, beta is SXY over SXX. Okay, so our beta hat should be. So this beta hat is this guy. Okay, and this one SE, right, will be S over sum of this. This is coming from the previous slide, right? How do you calculate this guy? It's coming from the sigma over sum of this. So this is what it is, okay? This cancel out the square root, right? So what's left is this guy, okay? And you take square, right? Everything squared, okay? And this sum of square, sorry, this is S square is coming from this guy. Okay. And S66 over S6Y is then, oh, sorry. So S6Y I need to think how I missed the proof here. Let's see. S6Y squared. Maybe I missed something. Oh, sorry. I missed something because that would be the thing that prove in the next slide to prove why this is this. So I need the next slide. So I need to show this guy is actually this guy. Okay. So the proof, just go very quickly. This same as this guy. Okay. And what I do next will be we replace alpha by its definition. Okay. And the next part will be this and this cancel out. Okay. Then you can take the beta out. Okay. Because square, you have square. So that's what's left here. This is S66. And this by definition is this guy over this guy. And then cancel out, so left you this one. Okay. So that's why you can write the numerator by this guy, and that is what you have here. And also why this is f squared, because this is you take t to the square, that become chi-square over chi-square over the standard chi-square 1 over n. So that was the proof. Since most of you are not interested, but that I hope I give you some idea behind. Okay. So what's left is a few slides that trying to utilize the model. Okay. So now with the model, so what, right? So question is, we now have the model. Okay, with this model. No, there's no difference. T and F the same. The T will be you test both sides. Okay. So the question is whether what's different between T and F for this scenario. For our case, T test for beta equals 0, you calculate T statistic, which is say beta hat over SC of beta, right? Beta hat, right? Minus 0. And the F test also is testing this. F is given by SSR over SSE over n minus 2. So this is Tn minus 2. This is F1 NO2. And you calculate this, T squared equal to F, in fact. And this you reject on both sides, right? So T0 and this you reject on both sides. And for this case, you would only reject on one side. So for this case. Okay, so that would be the difference. But if you reject here, you reject there, the same thing. So that's why we put it there. Yeah, because to test whether different from zero is the most important thing in one regression. Okay, if you want regression, you say they're related, you need to show that this is different from zero, at least the minimum requirement. If you cannot show it, then the regression is not useful, right? Because it's not different from zero from statistics point of view, then you just use y bar. Why care about x? So that is the ultimate point, because you want to use x to a variation of x to explain variation of y. And if y by itself alone, y bar is enough to do the job, x is not helping, right? Then it's not going to be helpful. Is that clear why we're doing here? So what is left is just a few slides. Okay, so it would not be too, it will be very simple. So just bear with me for a few slides, and you no longer need to listen to me, I guess. But just bear with me for a few moments, and then we just go again to the Excel, then we're done. Okay, so just to recall what we are doing is a bunch of points, right? And we want to have a regression line. Okay, and what's the goal of doing this? Why we care about running this regression? Why we care about finding the slope intercept, right? What we are doing is, right, we find the slope beta and the intercept alpha. Why I care about this, right? Why I care about this line and want to see whether beta is bigger than zero or not, right? The goal is the following. We want to use this model to help us to do prediction, right? Suppose I give you some value x, okay? So what would be the expectation? Okay, what should be with the line here, what should be the y? Okay, so the other question is, what is fh of the y? So there are two questions. Okay, given x, what should be the y we are predicting? Okay, should be what is expected value of x? Okay, given the model. Given the y, what is the model given x? Given with the model, okay, and what is the mean of x given the model? Okay, so they're different thing. Okay, this is mean of y, because when x comes out for the same x, you can have many y, right? Possible, because y is coming from the model less. Okay, given the same x, you can have different y because there's a error term here. So you will have somewhat like this, right? Okay, if it's normal, then something like this would happen, right? You will mainly hinge on the center point, but it can be anything up or above, depends on the realization of this error. Okay, so given the x, there will be what should be number, right? But also you can also care about, because many number, you also care about the average of this, right? This will be smaller. Okay, that will be smaller. Okay, you care about this guy, this will be smaller. Is that clear what we are doing? There are two things we are using the model. One is to estimate the mean of that. The other one is looking at the actual response. So, okay, so you'll become clear soon if I go to the slide, but hopefully you'll be more clear, at least mathematically. So I don't use new notation. Here we use given a particular value x0, so x0 is some value 3, 4, or 5, so some value. So what we have is with alpha hat, beta hat, once you estimate, we want to estimate the y given x equals x0, okay? So that is the graph here. Suppose you have x0, this is a number. What should the average y be? Because many, then what is the average y should be? Okay, average value. Okay, and the reason why this is the case is because alpha and beta are random variable. Okay, depends on what the data you draw. This is there's some variation, right? Because remember, we have variance of alpha hat, right? Variance of beta hat, right? So it's not a fixed number. Okay, so it is not. This is not equal to alpha hat, right? This is not exactly this number. It will be come up and down. Okay, and the variance of this, which we will try to prove, turn out to be related to the error term. Okay, and a bunch of stuff we try to prove. Okay, but you can see the number you pick further away from mean, okay, they will be bigger, the numerator, and the whole thing is bigger. Okay, so what it means is if you run the regression, okay, suppose the mean of x is here, okay, and if you are closer to the x bar, the variance will be smaller. If you're far away from it, the variance larger, right? Why? Because remember, the regression line pass through x bar, y bar, right? So closer to the x bar, y bar is the most accurate, but you further away, then actually will be much worse off. Okay, so here is the distance. Okay, and you take a square root, you replace sigma by s, you have this. Okay, so let's prove this particular guy very quickly and very briefly. Okay, because I guess you don't care too much about the proof. But let's anyway prove it. So just notation, Sx is sum of x minus x bar. So variance of this, okay, will be, so we'll use the most complicated formula here. Variance x plus y is equal to variance x plus variance y plus 2 covariance xy. Okay, so this is variance x, variance y, and 2 covariance xy. Okay, and remember x0 is a constant given, so that's why just take out right here. Behind is the formula we have is variance ax is a squared variance x if a is a constant. Okay, and from that we just use our result. This is what the variance alpha, and this is the variance beta had, and covariance this will prove in the next slide. Okay, and this is sum of x. Okay, so we just rewriting here to here. Okay, and I'm not going to detail. Actually, we do this. We have this step when we derive this. Okay, actually we write this, and actually we turn out to be same as this one. Okay, so I'm not going to. You can check back the slide. This is the same thing. So we just cancel out. Okay, so to this one is coming from the previous slide when we prove the second last step, proving the alpha. So this is coming, you can say directly to here because this is the step we use. Okay, so just to make sure that you see what I'm saying, is the proof is here, this step, this SXX. Okay, so this is the step you coming from here back. But anyway, I guess most of you are not interested in this one, but this is how you arrive this answer. So what is left is how alpha and beta covariance. So very quickly, alpha is, you can write in this way. Just this is beta here. This is y bar. And this is rewriting, okay? And you can see there are yi here. Just collect yi, it's yi. And because I and j are uncorrelated, okay? So that's why yi is the variance of y. Give you sigma, and you just multiply. And this multiply this, give you this guy, right? This multiply this, give you this guy, okay? And this sum of this will be 0 because summation of I minus 6 bar, this is 0, okay? And this is S6, okay? And you cancel out. So that's what you give here, okay? I guess most of you are not interested, so I would just rather brief on this one, okay? So I guess the important point is to how to use it, right? And the point estimate, right, will be the one give you x0. This is what we mean the model, right? This is the line, right? And just to remind you, this is a typo in the slide, it's a marginal error. So will be, this is the guy, right? This is coming from the previous slide, okay? And this is T M minus 2 alpha over 2, right? So that would be, this would be confidence interval. Okay, so that would be the key. Okay, so that would be this guy. Now, are you okay? This is what we call confidence interval for the mean response. Okay, this is y bar. Okay, and given x equal to x0. Okay, so now we have to look at the other one. Okay, so this one will be not easy to understand, but I hope if you understand the previous one, this one would be immediate. Okay, so as we go back to the picture here, okay, instead of estimating this, we're now asking this guy, what is the y? Okay, so the idea is a little bit more convoluted. So pay attention. This is the last few slides. So this is given x0, okay? So the response is y0 is not asking the mean of y, okay? It's not asking the expected this, okay? Given, okay? It's not asking this, it's asking exactly the 0, okay? This is your prediction, right? Given by your model, okay? And what's prediction error, we define this way, okay? Because this is what, right? Because this is x0, and the model we have y0, right? And if your result is y, okay? So this is the prediction error, right? Okay, you predict this, but actual number is this one. It's a prediction error. Okay, so the prediction error on average will be 0, right? So because the center is here, so it's something like this. So most of the time you will be at the line, but it can be up or down. Okay, so the expectation, this is generated from the model. Okay, and this generated from you, your model. Okay, this generated from population. So this is coming from the least square estimate, but this is underlying parameter. But by the Gauss-Markov Theorem, this is same as this guy. So that's why they cancel out, and this why cancel out. That's why it's 0. It coming from Gauss-Markov Theorem. And the variance of this, okay, which we prove, turn out to be very similar to what we have. This is what we have before, right? But if you instead not predicting the mean, but predicting individual response, actually is one more variance. Okay, one higher up. Okay, so that is the difference if you want to predict an individual result. Okay, so let's see. This is the standard error. Okay, so far this is the error of the prediction error. Okay, so let's see how come this is the prediction. Okay, so we need some little logic. Okay, so we know that the prediction error is 0, right? Because the error, the estimate, right, is 0, which will prove it. Okay, the margin of error will be given by this. This is something we haven't seen. You have the same idea. Okay, so the prediction error, right, would be this minus this. Okay, so then you add this, right? So you go, I want to predict this guy. Okay, so you add this to here. Okay, so that's why you want to, the prediction error will be 0, have this variance. You just want to know the prediction error for this, you just add this guy in. Okay, so that will be the prediction error for individual response. So that is the proof. Okay, so let me repeat, this is very important, the distinction. Because prediction error is 0, we can characterize we can know the prediction margin of error, and we know the prediction error is following this form. Okay, but you note that this guy, right, and the prediction error only different by this guy. Okay, so we just add it back. Okay, that will be your prediction interval. Okay, so this is usually don't call confidence interval. This is called prediction interval because of the you're looking at the individual to distinguish what was the mean response. So it's individual. Okay, so but the only difference is the error term, right? Is you notice the only difference from here to here, okay, is only the error term, which the difference is only this part. Okay, so if you want to predict the individual's response rather than the mean response, that would be just +1 or negative -1. Okay, so that would be the goal. So here comes from the last slide. Okay, last slide, the proof. Okay, so just very quick proof. This and this actually have the covariance 0, so just like sum of the variance, and this guy is sigma square, so that's why there's one more. Okay, so this is a proof, and I guess we should go to the Excel. I guess that would be the most important thing we want to do. Let's go to the Excel. Can you see the Excel spreadsheet? Hi. Yes. So let's do it again because we have time, I guess. I guess we can go over it carefully again. So you have to put data. I don't know what the data is, but just make up some data. Okay, I just make up some data here. We can see the data. Maybe I just make up more. Okay, Suppose to pick up this data, okay? The first thing you do, the data, you should just, you do analysis. The best thing is to look at, if you want to do regression, it's always good to have a scatter plot first. So it seems like negatively correlated, okay? But we don't need the plot now, okay? So what we are doing now is to do total data. And data analysis. Okay, and then you choose regression. Okay, regression comes out. Okay, and then you choose what's y, what's x. Y is from here B1 to B9 for my case. It may be different from yours. X will be, for my case, will be A will be A1 to A9. Okay, and we have label in the first row, so label here. And where we want to output the answer would be this D1. Is that okay? Now let me know if you can't follow. Okay. So now we just left to explain is this ANOVA. Okay. Yellow part. And we now do R square. Okay. So that way we know it already. Okay. So that would be the something we'll try to explain. Okay. So first, look at the ANOVA. The first result you can see is, you notice, I want to highlight this point first. It is fun and this one the same. Maybe not surprising to you because F-test, ANOVA F-test are the same thing. Okay. So they're the same. Okay. So that's why I said, or that's why we said the F, whether you do a t-test and F are the same. Okay. And I already told you how you arrive at SSR and SSE and SST. Okay. Let me write that down. Right. This is SSR, right? The sum of the yi minus yi hat. Sorry. Okay. And this is SST, SSE, right? Summation yi hat minus yi square, right? And this is SST. I'm not going to write that down. I think you can check the formula, right? And this divided by this gives you this guy, right? This divided by this gives this guy, right? And this over this gives you this, okay? And you can check this F1 and 2 alpha, okay? And this is 95%. But they give p-value, right? So same as this guy. And this R square, okay, which is very high, okay, which is not surprising because you see the scatter plot is very nicely on the line. So it basically said it explained the 93% of the variance, okay, the variance of X explained the 93% of the variance of Y. Okay. Okay, so I guess that's pretty much I want to say. And you can use this standard error, okay, to do all the calculation we want, right? Because this is the is the S, right? And then you can do all the calculation we want to do the interval estimation and everything there. And yes, I think something, there may be some function I can explain one more, but I guess this should be fine. I guess so far I think should be fine. I guess that's pretty much we want to cover in all the courses. And so the next week, because we don't have class on Thursday, so next week we will have the quiz and also review of the material. Oh, so here is p-value. Oh, you mean the yellow one, right? The p-value means whether beta is 0. So good question, whether beta is 0 or not, this hypothesis testing. So this less than 5%, so that's why you reject this. It's not equal to 0. So next, any more question? So next week we will have a quiz and also we will have Q&A, and also maybe if no have question, then will be review. We will just do a review. Yes, then Thursday we have a quiz. Yes. So please, because we finish this, I will upload the assignment to the Blackboard, the last assignment. But again, I give you more time to do, so it will be the end of the semester, because of I think you prepared the exam, the quiz, everything there. So I just delay it until the very end of the course, but that will be the end. Okay, I don't have further thing to say because we finished everything there here today. So so goodbye. Thank you. I'll see you next week for the quiz. Also, there's some question here is we reject the significance of F. Okay, so the first question asks reject significance of F. Okay, this is the p-value significance. This is p-value. And what's the purpose doing mean response, individual response? Oh, it's the prediction. So someone asked me why we care about this. Okay. So we have, this is a y hat. Okay, y hat is what? Will be this intercept number, okay, plus x times this coefficient, right? So this will be the regression line. Sorry, I need to things will be 4. Okay, so this will be our prediction model. Okay, and we want to know the common, because we estimate this prediction, right? Then we want the interval estimate. So if you want it to be mean, then you will add a smaller CI. If you want a individual, then you will make it bigger. Because this gives you the x, this will predict the y, right? It's a line, and depends on whether you are predicting the average value or individual value, then you add that back. Is that clear what we are doing? Just like you predict everything, you have a confidence interval. Just what that is said is we have this estimate, and we want interval, right? That's only same as what we have done. So there's nothing new here, but just to show you, okay, this is the variance, is to add and subtract, add that there. Or if you basically just like, just to remind you here, right? The value, I predict this is the case. I'm telling you that how big is the interval. Depending on you estimate mean. If you estimate mean, that will be the red one smaller, but if you estimate individual, they're bigger. Is that clear? Y hat? Oh, Y hat is just the line. Y hat is the line. It's what you're doing all the time is this guy. This is the model. This is the Y hat. It's the line. It's exactly the line. You can see the line. The line is a Y hat. Also Y bar. Y bar. Y hat. This is Y hat. Y hat is the value from the regression model. If you still look at the slide, our hat is just the regression line. Or if you do it here with Y hat here, same thing. Is the coming from the estimated model is a Y hat. Is that clear? Mean response is to show, Y hat. Well, because the mean response is the following. Okay. So look at this model. Okay. So this is the model, right? And what you estimate is this model. Okay. And in the real world, this is subject to this guy, right? The underlying generation. Given the same X, you will be subject to movement, right? No matter same X, you observe multiple times, you will be subject to different error. Okay. So what it said is the mean response is saying that the Y hat, Y hat is not changing, but the fact that given you different X, okay, and you will have different Y. Given the same X, you observe it multiple times with different Y, right? So according to your model, you predict you should have different multiple, you're the same Y hat, but what would be the value of this? Okay, to put it this way, the interpretation in some sense a little bit more complicated. Okay, in some sense you are right in the sense that because you have each time when you do sampling, you have different alpha and different beta, then with different Y hat. Actually, that's how different Y hat changes. This is you can imagine in that sense. But the interpretation is how, if you use the model, what should be the how this value changes. Yeah, I mean you're right to consider that. I mean, because alpha and beta are random variable, it changes, and then that's why this guy changes. But ultimately, it's because of the error term there. So if you read, the interpretation is more like if you repeat many times, this is, there will be same idea. So suppose you repeat sampling, then you have many alpha and many beta, and then that will be the same interpretation. 95% of them will include this value, 95% is not. So the same idea. I hope I answered your question. A little bit tricky, this one. A very good question, thank you. This is one very good. Any further question? Of course, I'm here to answer your question you might have. Sample for research, I would try. So it really depends on, well, it would be very similar to what you would do in the assignment 1, except you saw the result, right? So you just said, I run the regression, what is the equation, or you want ANOVA, you want to show, let's see if I can come up with some sample, but usually just report, you should present, suppose depends on what you are doing. If you're ANOVA, you just show us the, you just show us whether they're related or not, right? You run the regression, you can show us, say, the regression equation, the R square like Excel, or the scatter plot. So you just, because just combine what you learn, right? Just report what, remember the report is just one or two pages, right? If I remember correctly. You don't report a lot of stuff. Did I answer a question? I don't know. Fancy report. I don't know how fancy you are, but just what it's doing is the business, is a business class, right? So we're expecting you produce some what business professional report, right? So that's why I'm not asking you to produce a very long report. It's a very short, right? I don't ask you to write a long report. It's a short report. It's like executive summary. You just show whatever you want to show. If you say they're related, they're not related, what is your interval estimation, right? So you just try to look at the newspaper, how people report statistics, right? So that would be the easiest way to pick up newspaper, maybe Financial Times, Business Time, or there are many people reporting how, especially look at how people report the election poll. The recent election poll, they're easy to do. I hope I answered a question. I think the sample the same as what you do the sample one. You just report. I try to see if I can find some sample, but they're the same. Yeah, I can try to figure out some, but it will be okay. I'll try to do that. Yeah, I think the appearance will be important, right? Because it's a business application. But I will upload the format. Try to see if it can help. Yes. Any more questions? If no, then we'll end the meeting. So have a nice weekend. I will see you on next Tuesday for the okay, bye-bye.